In today's class, we will do some problem based on meter bridge. First, take down this problem and then we will try to solve it. In a meter bridge, the null point is found at a distance of 40 centimeter from A. In a meter bridge, the null point is obtained. The null point is obtained at a distance of 40 centimeter from A. If a resistance of 12 ohm if a resistance of 12 ohm is connected in parallel with S, the null point occurs at 50 centimeter from A. The null point occurs at 50 centimeter from A. Determine the values of R and S. Determine the values of R and S. In a meter bridge, the null point is obtained at a distance of 40 centimeter from A. If a resistance of 12 ohm is connected in parallel with S, the null point occurs at 50 centimeter from A. Determine the values of R and S. That is a question. So first you take down this meter bridge also. In the problem they have given the meter bridge. This is the given meter bridge. We have point A here and B is here, and as we know, between A and B we are connecting a battery. R this is S. In a meter bridge, the null point is obtained at a distance of 40 centimeter from A. If a resistance of 12 ohm is connected in parallel with S, the null point occurs at 50 centimeter from A. So now in this case, like in the beginning, the null point is obtained at a distance of 40 centimeter from A, and then when you connect a 12 ohm resistor in parallel with S, the null point is occurs at 50 centimeter from A. So we need to find out what are R and S. Now we know in a meter bridge, so we'll have a galvanometer also. So generally we take this as L. When this is L, the remaining will be 100 minus L centimeter. And 100 minus L centimeter or 1 minus L meter, if L is in meter. That we have seen when we did the theory part. Now we'll take the first case. So this is the first case. I'll write here only. So let me write it as solution. applying the balance condition, we will have R by L, or sorry, R by S is L by 100 minus L. Applying the balance condition, we have in the first case R by S equal to L divided by 100 minus L. And given that L is 40 centimeter in the beginning, substitute that L is 40 centimeter, 100 minus 40. Therefore, R by S is equal to 40 by 60, or this implies R by S is equal to 2 by 3. R by S is equal to 2 by 3. This is the first case. Now when 12 ohm is connected in parallel with S, we will do the same condition. When 12 ohm is connected in parallel with S, when 12 ohm is connected in parallel with S, when 12 ohm is connected in parallel with S, the equivalent of R and the equivalent of 12 ohm and S will be ohm and S is given by the equivalent of 12 ohm and S. Into S divided by 12 plus S. 12 into S divided by 12 plus S. Therefore, once again by applying the balance condition, we can write R divided by, or you can write here, once again applying the balance condition, once again applying the balance condition, we will have R divided by 12S divided by 12 plus S equal to, now in this case L is 50 divided by 100 minus 50, that will be equal to 50 by 50 or 1. This we can take as equation 1. So now we have R divided by 12S divided by 12 plus S equal to 1, or R is equal to 12S divided by 12 plus S. And from equation 1 we can write R in terms of S. So here we have R is 2 by 3 S. R is 2 by 3 S. Let us apply that here. Also we have R is 2 by 3 S. 2 by 3 S is equal to 12S divided by 12 plus S. Now let's simplify this and we will solve for S first. Now from this we can write it as so 2 ones are 2 and 2 6, so 12. So from that I can write, now cross multiplying we can write, and S will also get cancelled. S and S will also get cancelled. So we can write 12S is equal to 12 plus S. 12 plus S is equal to 18, or S is 18 minus 12. Therefore S is 6 ohm. S is 6 ohm. And we have R is equal to 2 by 3 S. R is equal to 2 by 3 S, which is equal to 2 by 3 into 6 equal to 4 ohm. 2 by 3 into 6 equal to 4 ohm. Therefore, the values of R and S are 4 ohm and 6 ohm respectively. The values of R and S are 4 ohm and 6 ohm respectively. Respectively. The values of R and S are 4 ohm and 6 ohm respectively. This is how we can use the meter bridge to find out the unknown resistance. So the balanced condition of the Wheatstone bridge is obtained by the balanced condition of the meter bridge is actually obtained by the Wheatstone bridge itself. So here we have used the balanced condition of the Wheatstone bridge itself. So at the end you can remember this point. I will just write a note over here. In case of meter bridge, at null point condition, the bridge is balanced. That is, we can apply the condition of balanced Wheatstone bridge. We can apply the condition of balanced Wheatstone bridge. In case of meter bridge, at null point condition, the bridge is balanced. That means actually you can apply the condition of balanced Wheatstone bridge, that is P by Q is R by S in case of Wheatstone bridge. The same condition we have used in this sum, that is R by S. R by S is L divided by 100 minus L. So this meter bridge is actually, you can show this bridge as a Wheatstone bridge also. If I write that, I'll just write it here. So this R will be like this. R, yes, and there will be one resistance here that is proportional to L, you know. So the length is L, or I'll write it as a length only. The resistance of this is proportional to L, so this is L, and then we have 100 minus L. We have a galvanometer connected between these 2 points. We have a supply between these 2 points. Here this is the point A, point B. Therefore, we wrote it as R by S as L divided by 100 minus L. R by S is equal to L divided by 100 minus L.